let's take a look at these two problems. The first one is set up in the same way that we did the example. You have two logs. They're set equal to each other, so right away we can just equate the values inside those logs. So x plus 1 has to equal 2x minus 3. And this is a linear equation, so when we solve it, we just move all the like terms to one side. So subtract x from both sides, move the constants over to the other side. We get 4 is equal to x. Double check our number. When we plug that in, do we get positive values for each of those? Yeah, and in fact, we can confirm it. 4 plus 1 is 5. And here, 2 times 4 is 8 minus 3, also 5. So those are going to be consistent values. In the second example, here's again about as complex as it gets with this type of equation where you have multiple logs. And that is, you might have to condense logs on one side of the equation. So the right side already has a single log, so we're fine over there. This can stay, log 3 of 10 plus x. But on the right side, we want to condense it into a single log. So here, when we rewrite this, log base 3 of, and we're going to condense it. And when we condense it, it becomes a fraction, although you might not need the denominator. So if you look at the individual logs, the first value comes from a positive log, so it's going to be a factor of the numerator. The second value also comes from a positive log, so it also will be a factor of the numerator. So it turns out in this particular case, there were no values from negative logs, so we don't need to worry about the denominator here. So once we get to this stage, we can equate the powers. We get 2x times x plus 1 is equal to 10 plus x. And now it's just a matter of solving the resulting equation. So here, when we distribute the 2x, we see that this is a quadratic equation. So we have multiple variable terms, so we're going to move everything to one side and compare it to 0. So here we'll subtract 10 and subtract x from both sides, giving us 2x squared plus x minus 10, all equal to 0. So when we solve this, we can solve it either by trial and error, or we can rewrite the middle term. I'm going to just use trial and error because my first terms have to be 2x and x. My second terms are going to have to be either 1 and 10 or 2 and 5 in some order, one positive, one negative. So if I kind of test this and see, right, as far as 10 being in the first group, if 10 was a correct term here, then because of the 2x, I would have been able to factor a 2 out of my original form. So I know that it's not 10 and 1. So let me try 1 and 10. So my outers is 20x, my inners is 1x. Do those have a difference of plus 1? No. So I know it's not going to be that. So now I'll test the 2 and the 5. Well, again, I don't even really need to test the 2 because, once again, if 2 had been in this position, I would have been able to factor a 2 out of my original value. I couldn't do that, so there's no 2's there. So I'll test the 5 and 2 in this form. So my outer product is 4x, my inner is 5x. Do those have a difference of 1x? Yeah. And so you just have to determine which one. So it's a 5 here and a 2 here. And when you take your outers are 4, the inners are 5, so I want my larger one to be positive, so a plus in front of the 5. And this would be my set of factors. Once I have those set of factors, I can use the zero product rule, find x. X is going to be the opposite of my constant divided by my leading coefficient. And here it's just the opposite of my constant. And so I have negative 5 halves and 2. When I plug those back into my original form, would I get a negative in this first log? Yeah, so I know that that one can't exist. It's not possible. And what about the 2? When I plug a 2 in for each of these x's, will it show up positive for each of them? Yeah, and so that would be your solution.